Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to the video on reflections. And while I know everyone watching the video has seen their reflection at some point in time, probably from a very young age, understanding where this comes from a geometric perspective and being able to accurately draw this is what we're working on. I'm sure you've actually done these before. Maybe you were given one of those activity books where it had grid paper and half the picture was drawn and you had to draw the other half. That was using reflections. So one thing to keep in mind is that this is a rigid motion, okay? We're not talking about a funhouse reflection where the mirror kind of warps your status. This is something that is going to preserve the length and angles. Okay? In other words, this is going to be a flip, but it's not going to change size. In geometry, they're going to give you a pre-image and an image. So the pre-image is what you start with, and the image is what you end with. So it's really important that we understand how they're going to notate it. So they might say triangle A, B, C for the pre-image, and triangle A, B, C. If you do two steps, then they'll put two dashes for the second step. So that's how they indicate the difference between them. Okay. So you might see a pre-image. One, two, three. 1, 2. Here's a triangle, right? 1, 2, 3, 1, 2. I did something besides a reflection, but the legs are the same length. So this is an example of rigidity. Okay. Whereas, and remember, this is the pre-image. This is the image. What if I start with the same pre-image? Okay, starting with the same pre-image. Now this is not rigid. Something happened here, and we can go from one pre-image to the image, but it's not a rigid information piece. So that's really important that we have that rigidity going on. So make sure that when we are talking about our shapes that we understand that a reflection is a rigid motion. So here we see that we're going to reflect triangle ABC over line M, and we have an image. So technically this triangle ABC is our pre-image, and we need to get our image. Okay, so there's several steps we need to go through. So step 1 is we're going to find the slope of line M. It doesn't matter that there's not a coordinate plane, we just need to find the slope. So up 1 over 2, up 1 over 2, up 1 over 2. Looks good. So our slope happens to be 1/2. Okay, step 2. We need to calculate the perpendicular slope. So since this is up 1 over 2 and it's going up, we need to go down. And instead of 1 over 2, we're going to do 2 over 1. All right, so now step 3, we are going to draw a perpendicular line from each point through line M. So since we have a triangle, we're going to draw 3 lines. draw perpendicular lines through each vertex. And I'm going to be doing that in pencil. Okay, so starting from C, down to over 1, down to over 1, down to over 1. Okay. From B, down to over 1, down to over 1, down to over 1. And from A, down to over 1, down to over 1, down to over 1, over 1. Okay, I've done that. I have a perpendicular line from, ooh, that's not the best perpendicular line from C. Didn't even go through point C, did it? There we go. All right, so now we are going to use a compass to mark the pre-image points. Equal distance from line M. Okay, so sometimes you can count, and counting is fine. Like we can see that down to over 1 pretty much was perfectly on, but what we can do, make this even better, is I'm shrinking this in. Keep shrinking my compass. Compass is a great measuring device, right? All I'm doing is saying, hey, how wide is this? Okay, now a little bit more shrinkage. There, now I have the width, right? So I'm going to come over here, and right there is going to be my new B. Notice I put the little dash to make sure I knew that that was my first step. From B, not my first step in the triangle. Okay, I've got that measured. Come over here, make my mark. There is C. And there's that. And so there is A. And now I'm just going to connect my triangle. Okay, and if we were to fold it on that line, let me get it folded really quick. Fold my paper both ways. All right, so now I've got that fold crease. We can see how absolutely they would definitely meet up. There's those A's coming out at you right there. Yep. That's going to sandwich nicely together, so you can kind of look at that as your check if you need to. A transparency is also a way to do a nice check. But we have done, all we did was we drew perpendicular lines based off of the slope through our line of reflection, measured the distance, and copied it. Okay, so anytime you see our x-axis or our y-axis, they're telling you to do a reflection, and they're telling you over which line it is. Now, since it's vertical and horizontal, it's much easier because drawing the perpendicular lines and measuring the distance, we really don't even need a straight edge because we have grid marks, right? So let's test that out. We also already know the slopes of our x-axis and y-axis, so that's the other cool thing. So triangle ABC has A at -5, 6, B at 1, -2, C at -3, -4. Draw triangle ABC for our x-axis and our y-axis. So this time we're actually going to have the coordinate plane. So let's do our x-axis first, meaning the reflection over the x-axis. All right, so we got to get our pre-image graph before we can do anything. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. A, 1, -2, there's B, -3, -4, there's C. Okay, and remember we're reflecting over the x-axis. So we know the slope is 0, so the perpendicular slope is undefined. That's step 1 and step 2. It's kind of really easy to do those. So step 3 was to draw a line perpendicular to a reflection line. So with a flat line, we can do that really easy. And then because it's so perfectly straight, and instead of getting out the compass, we can just count. So since this was 2 below, we're now 2 above. Instead of 1, 2, 3, 4 below, we're 1, 2, 3, 4 above. Instead of 6 above, we're now 6 below. Okay, so we now have our image. In our image, A hat was left 5, down 6. B was right 1, up 2. And C, we went left and up. So because we were reflecting over the x-axis, what was down was up, what was up was down, our y values changed. In fact, they changed signs, because when you flip into the other quadrant, instead of positive, you're negative, which makes sense. So maybe you're already predicting something for when we do the reflection over the x-axis or y-axis. Okay, so we're going to do reflection y-axis here. Same pre-image, right? Whoa, I went off grid there. Let me fix my axes. It's always a good thing to draw a solid axis whenever you start. That way you know where 0, 0 is. So again, A started off left 5, up 6. B was right 1, down 2. And C was left 3, down 4. So our reflection this time is going to be over the y-axis. So we're folding in half. So some of you might already know your ordered pairs because you're using what you just thought about with the x-axis reflection to think about the y-axis reflection. So this time we have an undefined slope. So perpendicular to undefined is 0. So 1, 2, 3, 4, 5 squares left, 1, 2, 3, 4, 5 squares right. There's our new a. 1, 2, 3 squares, 1, 2, 3 squares. There's our new c. 1 square, so 1 square. There's our new b. And connect. And there we go. We do actually have that reflection going. So what do you notice about the points? Well, now we're right 5 up 6. B, instead of being right 1 down 2, we're left 1 down 2. And C, instead of being left 3 down 4, we're right 3 down 4. So when we reflect over the y-axis, the x value changed. So can you use that trick if you're trying to do that? Absolutely. Can you still go through the steps of draw my perpendicular line and measure the distance? Absolutely. But in summary, for that part, okay, if you reflect over the x-axis, your point x comma y will track or map to a point of x comma negative y. If you're reflecting over the y-axis, your point x comma y will map to that same point, except it'll be negative x comma y. So you can always do that. All right, so now what happens if we're given a slightly different scenario? Okay, so what reflection maps these 3 points to their 3 respective points? And this is a different setup. So what's going to happen here is a picture is really going to be worth like 1,000 words, right? That's how that saying goes. I went ahead and I drew a grid, but I numbered it by 2s just so it could stay inside the same window. I didn't want to have to draw a really big graph, so careful with your numbers. So 3, 2, 4, 6, 8. There's our C. 5, 12. That would be our D. And 4, 6. Here's our E. So maybe I should have drawn my letter C on the outside of my triangle. Check. Okay, so we're starting there. And we're mapping it to -8, -3, -12, -5, and -6, -4. So C, D, E. Okay. So I need them to line up. I need the D to line up to the D. So I'm just going to go ahead and kind of visually fold this paper, right? Make sure I just get one piece. I don't need to fold all the pages I have. But you can come in here and you can try to make everything line up. And then we can try to crease it. I'm not going to do a hard crease. But now we kind of see a line of reflection. It may not be perfect because I may not have folded perfect, but it gives us an idea that there's some kind of line out there that we have to have reflection. And that line has to be halfway. So there's a couple ways we can do this, okay? So we know that we have a straight line from C to C, because we're kind of reverse engineering that process and the steps we made. We have a straight line from E to E, and a straight line from D to D. And you'll notice these lines are parallel, and they should be, because they should all three be perpendicular to this line. So we're going to have to come up with the equation of the line is really what we're going to have to do, and that's going to be, it's going to be a reflection over the line, and we have to tell it the line. So we can see that we have 2, 4, 6, 8, 10, up 10, 2, 4, 6, 8, 10. Looks like we have a slope of 1, right? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess I should have gone up 10, 11, and over 10, 11. So up 11 over 11, still a slope of 1. Let's check this one. We could do this as well. The slope from C to C. We can do y minus the y over x minus the x. 11 over negative 11. Oops, I did that backwards on the bottom. I was mixed them up in my head. I wondered why I got the wrong answer. 3 minus negative 8. Yes, that's a slope of 11 over 11, or 1. Y minus y over x minus x. That would be 17 over 17, which is also 1. And then e, 6 minus negative 4 over 4 minus negative 6. Yep, that's 10 over 10, which is 1. Okay, so the slope of all three of these is 1. So what's perpendicular to 1 over 1? Negative 1 over 1. So we know my perpendicular slope is negative 1. Okay, now remember that whole equidistant thing? So we need this to go through the midpoints. So we've got to pick one of them to do the midpoints of at least. Okay, we need the midpoint from E to E prime. And so that's going to be the average of your x's divided by 2, right? And then the averages of your y's, 6 plus negative 4 divided by 2. And when we do that, we get negative 2 divided by 2, which is negative 1, positive 2 divided by 2, which is 1. So now we have a point and a slope. Perfect. If you've watched my videos, I love having a point and slope because I can use point slope form. So y minus the y value equals our slope, x minus the x value, and since our x value is negative 1, it really means plus 1, right? Distribute. We'll get y by itself. And now we have the true reflection line. So start at 0, go down 1 over 1, down 1 over 1. Our folding was pretty good. This is a reflection over the line y equals negative x. So when it says what reflection maps CDE to the image CDE, we can say reflection over the line y equals negative x, because that was the equation we got. So what's going on here? Why would I need to know this? Okay, how can I use it in my real life? Like really, seriously. Well, let's take a look at this picture. If you're playing a game of pool and you strike the cue ball so that it goes this way, when it gets here, a reflection is going to happen, and it's going to happen perpendicular to this, right? So you can see how we have the slope from here to here. So we have to do the perpendicular, so right? So to get that to happen, we're looking at a second reflection. See how the edge of the pool table is perfectly between here and here? That's not an accident. So in order to get it to bounce off here and do this perfect reflection, we have to aim beyond and picture this point. That way you can get that reflection to work for you and you can hit the ball. Now, where's the ball going to travel? Well, it's going to travel along that line, and of course we've got another reflection coming in there. But if you have to bank your shot, then that works. So you can kind of picture how different things are going to work if you're doing a straight shot or not. But we can look at the travel of the ball afterwards, but that includes more variables, including your force upon your impact, things like that. If you're playing mini golf and you're trying to hit your ball to where it bounces off, that's another thing you can think of, is trying to use those reflections to up your game. So you'll notice that the people who are really good at the bank shots probably have a really strong grasp of visual reflections. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.